Okay, now like for linear motion, whenever we had to find the acceleration of an object, we use Newton's second law of motion. Sum of all forces is equal to ma. One might think, what should we do if an object just rotates when it is subject to several torques and it is spinning, rotating? How do we find the rotational acceleration? The good thing is it is the same way. For example, if you recall Newton's second law, sum of all external forces is equal to ma. It's going to be the same thing here. Sum of all external torques is equal, instead of m, we'll have the moment of inertia I, and instead of a, we'll have the rotational acceleration alpha. Sum of all external torques is equal to I alpha. We extend the same thought process to the concept of work. Work for linear motion is force times displacement parallel to the force. Same thing here. Work due to a torque is the torque times the angular displacement parallel to that torque. What about kinetic energy? Linear kinetic energy is 1/2 of mv squared. So here the half stays a half. Instead of m, like here, instead of m we used I, so we use I. And instead of linear velocity v, we use rotational velocity omega. So it's 1/2 of I omega squared. So in summary, Newton's second law of motion is sum of all torques is equal to I alpha. Remember that we use counterclockwise as positive by convention. Remember, moment of inertia is the equivalent of mass. How do we solve problems? Very much like translational problems. We draw a free body diagram and then write Newton's second law of motion.